Welcome to Module 2. In this part of the course, we will cover the principles of statics, which is the branch of mechanics concerned with bodies at rest or in equilibrium under the action of forces. A solid understanding of statics is essential for engineers because nearly every structure and machine must withstand forces safely and effectively. 2.1 Basic concepts and Newton's laws. Statics is built upon the fundamental principles of Newton's laws of motion. These laws explain the relationship between forces and motion. In statics, we focus on conditions where the sum of forces and moments acting on a body equals zero, meaning the body remains in equilibrium. Mathematical modeling and analysis are used to represent real-world systems as simplified diagrams, allowing engineers to calculate forces, moments, and stresses. 2.24 Systems. Forces can act in different configurations. Coplanar force systems, where all forces lie in the same plane, such as a beam under vertical loads. Spatial force systems, where forces act in 3 dimensions, such as a crane lifting a load. The resultant of a force system is a single force or moment that produces the same effect as the original set of forces. Determining resultants is essential for simplifying problems and ensuring stability. 2.3 Equilibrium conditions. For a body to remain at rest, 2 equilibrium conditions must be satisfied. The sum of all forces acting on the body must be zero. The sum of all moments acting on the body must also be zero. These conditions are applied to analyze beams, trusses, and frames in engineering. 2.4 Shear forces and bending moments. Beams are structural elements that resist loads applied perpendicular to their axis. When loads are applied, beams experience internal shear forces and bending moments. Shear force is the internal resistance to sliding between layers within a beam. Bending moment is the internal torque that causes bending. Understanding this is crucial because excessive shear or bending can cause structural failure. Engineers use shear force and bending moment diagrams to analyze load distribution and design beams accordingly. 2.5 Analysis of trusses and frames. Trusses are structures made of straight members connected at joints, widely used in bridges and roofs. Frames are more complex structures that carry both axial and bending loads. Analysis of these systems involves identifying internal forces in each member to ensure that the structure can safely carry applied loads. Methods such as the joint method and section method are commonly applied. 2.6 Friction between dry surfaces. Friction is the resistance to motion between 2 contacting surfaces. In statics, dry friction plays a key role in problems such as ladders leaning against walls or blocks on inclined planes. The coefficient of friction determines the maximum force before sliding occurs. Understanding friction is critical in the design of brakes, clutches, and numerous mechanical systems. 2.7 Moments of material, plane figures, and composite bodies. Moments of area, also known as second moments of area, describe how a cross-section resists bending. Plane figures, such as rectangles or circles, have standard moment values, while composite bodies can be analyzed by dividing them into simpler shapes. This concept is directly applied in engineering design, particularly in selecting cross-sections of beams and structural members to resist bending efficiently. Module 2 Summary. In this module, we explored the basic concepts of engineering statics. We discuss force systems, equilibrium conditions, shear forces and bending moments in beams, analysis of trusses and frames, friction, and moments of area. These concepts provide the analytical foundation needed to ensure that structures and machines remain stable and safe under load. Course conclusion. We have now completed the course on material science and engineering statics. In Module 1, we studied the fundamentals of material science, including atomic and crystal structures, bonding, dislocation theory, and classification of materials such as metals, polymers, ceramics, wood, rubber, and composites. In Module 2, we applied these concepts to engineering statics, focusing on force systems, equilibrium, shear forces, bending moments, truss and frame analysis, friction, and moments of area. Together, These two modules equip you with a foundation in both the science of materials and the mechanics of structures. This knowledge is essential for every engineer, ensuring that designs are not only efficient and economical but also safe and reliable.